Alright, time for another math easy solution to discuss derivative of inverse hyperbolic functions. So basically I showed you in my earlier video what inverse hyperbolic functions were and also what hyperbolic functions were, and I derived the formula for, let's say, sine of y equals sine inverse inverse sine of x. This one is equal to basically ln x plus square root x plus 1, and this is for basically x is any value, or you could go x is element all real numbers. This is how it's written. And then for cos inverse hyperbolic cos of x, this one's equal to ln x plus square root x squared minus 1. This is all square root. And this one is all defined for x greater than 1. This is my other video where I derived these. And then if you had the last one, tan inverse hyperbolic tan of x, this one, the derivative is just equal to 1 over 2 ln 1 plus x, 1 minus x. And this is defined for x basically less than, x is greater than -1 and less than 1, or basically you could also write absolute value of x is less than 1. So that's what it's defined for. So to get the derivative, you could just do derivative directly from this and or these ones and just get it directly. But this one is usually hard to memorize, and so the easier way is just looking at it separately. Like what I mean, you could do, let's say if you're looking at inverse sine of x, let's say this y is equal to that. And remember, this one inverse functions, all this means is you have x is equal to hyperbolic sine h of y, and then this is basically all inverses. So then you could just do implicit differentiation. This is a much easier method. So just do a derivative directly. So we're going to have 1 on both sides, and this is going to be 1 equals 2. Well, derivative of sine h is just, just cos or cosh y, and then using chain rule y prime. So we just used a derivative of this one. It's similar to remember trig. Yeah, it's very similar. This one, derivative of sine is cos, and same as hyperbolic sine. So then just rearrange this one, and we're gonna get y prime is equal to, well, dy over dx, and so in terms of x, and this is equal to 1 over cosh y. And then in that other identity, all you gotta do, the other identity which is similar to trig, you have this one cosh y squared minus sine h squared y. This one just equal to 1. And then if rearrange this one, we're gonna get cosh y is equal to plus or minus square root 1 plus sine hy squared. Oh, this is h there. So we got this one, but the graph of cosh y is actually greater than 0. You see, you can see the inverse video I showed the graph of this one. This is actually greater than 0, because this one, if you look at the formula, this one is just e to the x plus e to the negative x over 2. So that's what it's defined as, and this is going to be always greater than 0. So then we don't need this minus, so it's just equal to, well, plus 1 sine or hy. So we got this one for cosh. So then we just put this in here. So we're gonna have y prime is equal to 1 over cosh y, or 1 plus sine hy. And then from, well, the inverse, basically we know that, well, x equals to sine hy. So then this is just equal to x. And this one will just be equal to 1 over 1 plus x squared. And there's our derivative. Yes, there's our derivative. And similarly, if you were to do it for sine, so for cos right here. So let's say we had y is equal to cosh h -1 x. This one again, just using implicitly, or you could just do it directly from the formula for this, but that's hard to usually memorize. So just switch it here. X is equal to cosh y. And then similarly, just do derivative. We're going to have 1 is equal to this one derivative. This one is just sine h y. You can see my video on derivatives of hyperbolic functions. And then using chain rule. So we're going to have that. Now this one is going to be y prime is equal to, y prime is equal to 1 over sine h y. And then similarly, we're going to use the same identity here. But now if you rearrange it, you're going to actually have, it's going to be cosh squared minus 1. So we're going to actually have, well, basically, we're going to have, let's see, this is the identity we have here. It's proved in my other video as well. Equals 1. So if you rearrange this one, so this side, move this inside, we're going to have sine h y is equal to plus or minus square root of right here we have cosh squared y is equal minus 1. And in this case here, actually this one is greater than equal to 1 actually. So if you were to graph it here, or just look at again this one, this is cosh y. If you put in the smallest value this could be is basically when this is actually 0 here. When this one's actually, the smallest value e could be is, or as you go to negative infinity. This if you go negative infinity here, this one goes to 0, but this goes to infinity. So the smallest value is actually when this is 0, and this equals to 1. So that's the smallest value is to 1. So then, you can see my other video on that too. So basically, it's greater than 1, so then, or equal to 1, so then it's always going to be positive. So it's just equals to positive cosh h y minus 1. And then if we put into the equation again, we're going to get y prime is equal to 1 over square root cosh squared y minus 1. And this one, again, from our just from the definition inverse, how it looks, that's basically what it equals x. So this is x. So we're going to get 1 over square root x squared minus 1. And this is for all values of sine of all values of x. So we got this one. Now if we look at the last one, we have tan. And similarly for let's say y is equal to hyperbolic tan h inverse of x. This one again, it just equals to x is equal to tan hy, and this, remember definition of tan, this one is just sinh or hyperbolic sine of y over hyperbolic cos of y. So we got this these two right here, and then let's do derivative right now, and we're gonna get 1 is equal to, well, you see my other video, this is similar to trig. This one is just equal to secant a or hyperbolic secant of h times of y, then it is times y prime, and this is this one is just equal to 1 over cos this one is y. Actually, this is this is squared. This is going to be squared y prime. So this is just what this equals to, and then you can see my other video on the derivative of hyperbolic functions to see how I got this. This equals. So now, so if we were to look at that same identity here, we had cos h squared y minus sine y equals 1. This one, if we just divide these, divide this out by cos squared y divided by hyperbolic cos squared y, and then this one as well. I just divide everything out, so we're not changing anything. This cancels. We're left with 1 is equal to, 1 minus this one. This is just tan. That's just gonna be tan hyperbolic tan squared of y, and this one is equal to, well, this right here, hyperbolic secant. And then we just put this in there, so we're gonna get so we actually just rearrange this one. We're gonna get y prime is equal to 1 divided by this one is secant h squared y, and then right here is just this one right here, so this equals to 1 over 1 minus tan h squared y. And then again, if we look at the definition of this one, we got tan hy is equal to x. So then, yeah, this one is equal to x, and then similar to all the other ones, we just plug in the x. We're going to y prime is equal to 1 over 1 minus tan, I mean x squared. So this is our derivative for it. And remember, x is defined only for absolute value of x is less than 1, or x is greater than -1 and less than 1. So yeah, to recap, we'll just put a summary right here, put all of them together so you can see them and compare them. Summary. Okay. Yeah, so yeah, here's the summary. I just pasted them here. So basically, derivative of inverse hyperbolic sine of x is just 1 over square root this one, square root 1 plus x squared, and then for cosh inverse is just 1 squared x 1 square root x squared minus 1. For x is greater than 1 is when x all real numbers, and there's derivative of inverse tan hyperbolic tan 1 divided by 1 minus x squared, and x is absolute value is less than 1. Well, that's all for today. Hopefully you learned. Just keep these in mind, and stay tuned for another math easy solution.